Next week is finals. We're almost there. Let's see. Our final is 7:15 next Wednesday. 7:15 next Wednesday. But you can exempt this class. So 9 days till the final. No, no, no. This is not finals week. Next week is finals week. So, so we've got one more program to write this week. Then we'll be done with all of our lessons, and we'll just have the final next week. So we're getting right down to it. So let's see how many folks we missing. We've got 10. We're missing 6 folks. We'll give them one more minute here, then we'll get it going. So I went and saw Bonhoeffer. Is that how you said this at the movies this weekend? Bonhoeffer. He was a German preacher during the time of Hitler. So that was very interesting. Very interesting to see his story there. I don't know if the movie was well done. It was kind of hard to follow. I don't think the director did a great job in getting it where you could always understand what period of time. He kept jumping back and forth through time, but you didn't really. You had to kind of figure it out. It didn't tell you 1934, 1940. It didn't tell you the year. You just had to figure out just before or after he was imprisoned by the Nazis. Yeah. But it was interesting, a lot of good stuff. But yeah, Christmas is coming. We've got this week. We've got our final next Wednesday at like I said, 7:15 in the morning. You'll have an hour and 55 minutes for the final, but it won't take you that long, surely. But yes, you can be exempt. So if you've had no more than 4 absences in here or in advisory, no more than 4 tardies, no missing assignments, everything's turned in, and your grades at least to 75%. Did I cover them all? Well, no fees or fines, but we don't have fees in this class. So, yeah, I think that's it. So let's jump into our lesson here. Let's see what's going to wrap up our semester. All right, go to our grade screen, scroll down to the bottom, and we see creating functions 3.04, and then we see the first semester final exam. I put a due date of next Friday at noon because I have to turn all the grades in. So I put that in there. So just to remind everybody that's it. Grades are permanent and final. Creating functions. If you want to, let me mention this real quick. If you want to be exempt, if that's a possibility for you, you haven't had too many absences, all that kind of stuff, you need to have everything in by next Monday morning. Because next Monday, I'll have to send the final exemption emails to say, yes, you've got everything turned in. Your grade 75% or higher, no absences, you are exempt. But I'll have to determine that by next Monday morning to give you time to be exempt for Wednesday. So you've got 1 week from right now, basically, because I'm going to say 7 a.m. next Monday morning. 1 week from right now to have any missing assignments turned in so that that's one of the qualifications for exemptions. So, all right. Now I got that there just to remind everybody because I need to announce that in all my classes here. And I need to put it up an announcement in Google Classroom as well. Creating functions. Now this is this is where we've always had the main function where we define the main function at the beginning of our program. We're going to learn how to create other functions. Some of you have been playing with this already. Organizers unite in single file, please. Packing is the pits. Yeah, that looks like a familiar sight there. Mashed shoes, wrinkled shirts, balled up socks, filling all the single space, leaving nowhere for your chargers and deodorant. You're going to want to pack those. Problem is you need all of it. So the answer is we've got to do a little bit more chunking, a little bit more organizing, arrange items in a certain shape and space and size and spaces that make the most sense, as well as items you'll be using together, like your toothbrush and toothbrush. Got to pack those in the same place. Helps fit more stuff and find what you need more quickly. So this, as you've probably already guessed, also applies to programming. So after this lesson, you'll be able to describe the purpose of a programmer-defined function, demonstrate how to divide a program into smaller tasks, how to call a function, identify values passed as parameters to a function. So let's take a look at page 2. It's a pretty short lesson. So let's talk about the main function. Now, we've used that in all of our programs. Well, some of you missed points because you didn't put a main function in, but you definitely have to have a main function. That's the one that opens each of your programs there. It's easy to overpack it with tons of code. We can make the main program, many, many, many lines, adding more and more until it's finally overstuffed, like that suitcase that won't close. Enter program defined functions. They're basically long lists of instructions that a program is broken out into chunks of code. The math module and the Turtle Graphics module both include libraries of function that chunk larger work into simple code, like print, the power function, forward, left. They're all programmer-defined functions that contain code that makes it work. All we have to do is just call that function, right? Tell it to print something. Then Python retrieves the code for that function. And so far, we've been using other programmers' functions, people that wrote the function print, people that wrote the function power, forward. But now we're going to write our own. So let's roll over the parts of code to see how to define a new function. First, you have to define. You got to use that def, the Python keyword, in case you're defining a function. This function called say hello. This is the name of our new function, say hello. And then this is the parameter that our function needs. And that'll vary depending on your function. That can be all kinds of different things. And they'll be listed in parentheses. If it doesn't need any, then the parentheses are empty. Like our define main, we don't have any parameters we have to have. That's why we have empty parentheses after define main. And then, of course, we have to have that colon at the end. And this one says print hello name. So this was a function that we just sent the name to and then defined. So let's check out this tutorial right here. We have a video to watch this week. That's unusual in this class, but we actually have a video that shows how this works.
Let's write a programmer-defined function that will print the happy birthday song. First up is to identify any repeating code that you can use to write your function. Let's use this block of code, since it's likely you'll be singing happy birthday more than once. Your function will need a name, so give it one that describes the action it will do. Type the keyword def and your new function name above the main function. You'll need a parameter, a value the function needs to work. In this case, it's someone's name. To create your function, write the block of code under your new function. You can create new functions using existing blocks of code so that it can be repeated as needed without having to reprogram each time. To use it, in the main function, call your new function and it should display the output. Now, every time you want to print the happy birthday song, all you have to do is call your new function and the code.
All right, that's pretty cool. I'm going to jump back here to the end of this. Notice, look, Ringo, Paul, John, George. They did that 4 times, and in the main code, all they had to do was, let's back up to where it shows it. They have their defined function. The program actually starts right here at define main. Starts right there, and then the first thing it does is it sets name equal to Ringo, and then it calls the function. And it sends that name up to that function, and it goes through there and goes, happy birthday to you, happy birthday to you, happy birthday, dear Ringo, happy birthday to you. And after it does that, it comes back to where it was in the main function. We reset the name and give it a different value, and we call that function again. So the program starts right here, jumps up, goes to that function, comes back here, jumps up, goes to that function, comes back here, jumps up, goes to that function. So that's how writing our own functions, define, sing happy birthday with name as the parameter, we can repeat this over and over and over again without having to keep typing it or keep copying and pasting it in our main function. So that's what we're going to be playing with this week. So let's go to the page that has some practice programs for us. Making your own function. Time to pack your own suitcase. So you read the programmer defined functions. Watch us make one, and now it's your turn. You can create functions for all sorts of tasks, even to draw a tree with Turtle Graphics. As you write your own functions, first you're going to identify the code that you want to put in the function. I need some code that I might want to repeat again. Is there an action or set actions that you could chunk into a function? Then we're going to define the function. We'll give it a name. These are often verbs like print or calculate total or whatever, but they should relate to whatever the function is going to do. Give it a good name. So use the define function to define your new function name. Define, say hello. If your function needs specific values to work, put those in the parentheses. It could, if you have more than one, you put a comma between them. If it doesn't require any values to be passed, it'll be empty. But let's go down and look at some of the sample programs. These are what you should be playing with each time you learn something new. You should come to this page and read this on the right, the instructions, and then play with the program. Change some things, see what happens. Writing functions, import turtle. Okay, here's our define main. We named our turtle Dally and told speed of 10. And this is drawing a tree. And it's going to move to a position. So it starts out going to the position 0, -20. And then turns left 90 degrees. Okay, so it hadn't drawn anything yet. It's just moved it and turned it the way it wants to go. First thing happens is it draws a trunk. So get the brown and go forward 60. Okay, so there's a little trunk. Then we draw the leaves. Said, okay, pick up the lawn green, turn right 90 degrees and make a circle of 45 diameter. Then it's going to move and draw a flower. Pick your pen up, because I don't want you to draw a line across the page. Go to this position, 20, -20. Turn left 90 degrees and put your pen down. And now let's draw a flower. First, going to do a dark green stem, 25 pixels. Going to change to hot pink, turn right 90 and make a circle of diameter 10. And that's the end of the function. So let's look at it. There's our tree and there's our flower right next to it. So it drew the stem, made the circle. Then we moved it to a different position by picking the pen up and then drew a little flower. Okay, so we got a flower and a tree. Let's go to the next example here. Edit the program to draw a second flower. It should be orange and in the position 48, -10. Okay, so let's see if anything changed. Let's run the program. I don't think it's changed. Okay, that's still the code they had. Tree, trunk, leaves, flower, stem, petals. So if we're going to do another one, let's copy this code. All right, instead of having to write all that again, let's copy it. And we'll go down here underneath it and paste. Okay, I'll put a space in there. Okay, here is draw a second flower. And they said we should be at 48, -10. So let's move to that position, 48, -10. And this one should be orange. Oh, the stem is still going to be dark green. We'll leave that, but we want the flower itself to be orange. And that should do it, because we just copied the same flower up here and we drew it again down here. So let's run the program, see if we get our second flower. There it is. So it went to position 48, -10, and drew an orange flower. So yeah, to draw a second flower, you can just copy the code under draw flower and change the color and position. So now we're down to 56 lines for our code now. All right, let's go over here. Read the code, try to protect the output. Oh, we have a new function, define draw tree. And this has all of the draw tree code that we had in the last program, but it's over here separately. And then, oh, we have a draw flower. And here's all the same code that we just had drawing a flower. And here's where our program starts. Our main program doesn't start right here. So Python will skip all the way down to here. It won't do those other functions because that's not the main function. And what happens when we get here? We name our turtle Dally. We set the speed of our turtle. And we tell it, using this turtle name, go to that draw tree function and run that function. So it'll go up here. Draw tree has T. So when we sent Dally, Dally takes the place of the T. So now it knows this is Dally, set the position, Dally turn left, and it will do all of that function. And after it's through, it'll come back down here to the main function. It says, okay, I just did that line. What's next? Now it sees, oh, I draw a flower. So it'll go up here and do the draw flower. So when we run this, it looks just like the program before, but we've broken those functions out separately, which allows us to repeat those really easily. 3 functions defined: draw tree, draw flower, and the main function. The main function's only, look at this, very, very short. It fits on the screen. That's the whole main function. Because it calls these other functions to take care of that. So, all right, let's go to the next sample. Look over the code, select run program. Everything works. All right, so import turtle, draw tree. There's that draw tree function. There's the draw flower function. Here's the main function. Okay, this looks just like what we just had. So I don't think we should go see anything different. Let's run it. Okay, that's the exact same thing. So let's explore some common errors with functions. Try deleting keywords and symbols like define or the colon. Delete the T in the parentheses, and try removing the indentation of the code inside draw flower function. So let's play with it and see what happens if we miss something. Like if we didn't have the colon after define tree, what happens? Line 5 gives us an error. So you see an error, bad input on line 5. Did I miss something? Oh yes, I didn't put the colon afterwards. What if I don't put the T inside there and I just do define function? Look, it's just like define main. What happens now? Draw tree takes exactly 0 arguments and 1 is given on line 43. So in line 43, when we called the draw tree function, we sent it the parameter DALI. Oh, here, use DALI. And it goes up here and says, what do you mean use DALI? I don't have anything I'm supposed to use. This is empty. It's like, oh, okay. Let's put that parameter back in there. Now it's happy. Again, if we don't indent things inside of a function, we'll just do that one line. Bad input in line 24. Yes, because this jumped ahead of the main function because it's indented the same as define main. So that's the first thing it found. And it's like, wait a minute, I don't even know what you're doing. Got to have everything indented inside the function. Just like we have to indent everything inside the main function, you have to indent everything inside these functions as well. Notice we don't have an end to these functions. See, the main function, we have to put this at the end because that's the main function. These, when they end, they just end. All right. Let's look at the slide 5 for this. Read the code, predict the output. Import turtle. There's our tree function. There's our flower. Oh, look, we've got T and C. We got 2 parameters now for draw flower. T is the turtle, C is the color. So it moves this position, and the stem is always the same color, dark green. But look, on the color for the petals now, that's defined in the main function. So here's our main function. DALI turtle.turtle, DALI speed, draw tree using DALI, and then draw flower using DALI, and we'll make this one red. Okay. If we change it right here and say, instead of red, let's make this blue. Now it's a blue flower. There's 2 parameters listed, T and C. So we can put whatever color we want right here in the main function without having to go up and change this every time up here in this function. All right, it's going to get better here. Let's look at this. Draw tree, still just a T. Now look at draw flower. Wow. T, C, X, and Y. T is the turtle, C is the color. And the position is X and Y. Set position X, Y. This is going to be very useful because now, look at this. We can use draw flower twice to draw 2 different flowers with just 1 line of code because we've already defined the function. We already know how to draw the flower. But we're going to draw one at 55, -20 that's red, and then we're going to draw a gold flower at -20, -25. Oh, look at there. So we can copy that copy. Oh, I'm pasting it, but I gotta fix the indentation there. Okay, so now let's choose two more. Let's do a yellow. Well, yellow's too close to gold. We'll do blue. I don't know if I should capitalize that or not. And let's see, what other color can we do? We can make a black flower. That would be pretty wild. We need to move it somewhere else. We don't want to draw it on top of the other flowers. So let's change this one to a positive 20 and negative 10. And this will go to negative 40 and 0. How about that? So now we're going to draw 4 flowers, and we're able to do that just by writing one line of code per flower, because we've got a function up here that will keep repeating this function. It'll keep repeating this function every time we call it in our main function. Run program. 1 flower, 2 flower, 3 flower. There's our 4 flowers. We added 2 flowers just by adding 2 lines of code. A blue flower and a black flower. That's pretty cool. Let's do another one. Let's do another red one. And we'll go to negative 60, negative 5. There we go, another red flower. We can add flowers just that easily by one line of code, because we've defined a function that will draw the flower for us every time. And it's got 4 different parameters we have to send it, because we want to change the position every time. We want to change the color every time, but we're using the same turtle, because every time we send the same turtle. Dally, 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 right? Using the same turtle. We could have more than one turtle running. We could send different turtles. But that's pretty cool. Let's look at the last slide we have here. Modify the draw tree function so the color and position can be passed as parameters. Okay, so we see that right here, color and parameter. So we could do the same thing, adding a color, an X and a Y, just like we did. I mean, not a C and a Y, I mean X and a Y. X and a Y. So instead of position being at 0, 20, we can say it's going to be wherever the parameter is set to. And, oh, this I want to be the color, C. And so instead of brown, the color will be whatever the color is, whatever C is. So we could draw multiple trees. Oh, well, I guess I should leave the trunk as brown and change the leaves. Let's do that. Let's change the color of the leaves. Okay. And then the flower already has all the parameters. So draw a tree, and it just set dally. Now we got to send it more, though. What color we want it to be? Well, let's do green for the first tree. And we'll do the tree at, well, let's just do it at 0, 0. And it wants us to draw at least 3 trees, and then add more flowers. So we can do that. So let's run our first one to make sure our first tree. There's our first tree. First tree is green. Now we're going to draw another tree. So let's copy this line of code and paste it twice. Okay, hit enter. Hit enter. All right, we've got 3 trees now. Now we need to change. It's fall now, so maybe this one's turning pink and this one's turning yellow. And we need to move our tree. So instead of drawing it at 0, 0, I'm going to draw this at negative 50, negative 10. And if we don't like where the tree is, we can just move these numbers, right? And we'll draw this one over at 50, negative 20. Oh, not negative 200. All right, let's see how those 3 trees look. First tree, second tree, third tree, and then there's all the little flowers. I already got another tree at I got a flower at negative 50. Let's move that to negative 60 for the pink tree. I'll move it over farther. Wait a minute. Why is our stalk of our tree the same color? Did I change that? Draw a tree. Oh, I changed the wrong thing on pin size. What did I do that? What was the pin size? I messed that up. I'll just make that a number. This is what I meant to leave brown. I changed the wrong thing. Oh, there it goes. Fat stalks there. That's nice. I like that actually. So we're going to leave the fat tree stems at 10. But let's move this black tree. It's a black tree? It's supposed to be yellow. Oh, I didn't spell yellow right. I left off the W, so it's making a black tree. Let's move that to 55. Like I say, just play with these numbers to get things where you want it to be. There we go. And now let's add more flowers. So we've already got these flowers. So copy, paste. Oh, putting the extra indentations in there. Let's see. We've got pink, yellow, red. We'll do blue. Blue flowers are not that common, but we're going to make some on our screen. There's a blue one. And what other flower can do? Pink, red, orange. I don't know. We could do, well, green's not really a flower color. Let's do crimson, just a different red. And let's move the other flowers. See, where do we have flowers at? We have them at 45, 70, negative 20, negative 50. Let's put one at negative 10. And this will be at 0 or negative 5. How about that? And then we'll put one over at negative 70 and just at 0. All right, let's see that. Should have 3 trees and 6 flowers now. There we go. And we can just keep adding flowers all day. We can just keep calling that function over and over again. So now you can see how a function is very, very handy to be able to repeat lines of code without having to keep writing the code over and over and over and over again. So that program I showed you last week that I wrote, where I drew the little house and the tree and the Christmas wreath on the door, all of that, that was using functions like this. Let's see. All right, that's the end of the lesson. So let's look at our assignment, and then I'll pull up that in there. So if we go to our classroom, go to the classwork page, we have a template for our last program of the semester. You're going to write a program to draw a picture by defining functions, just like this one in there, and using Turtle Graphics. So use Python idle, have comments with your name, date, short description. Make sure you have indentation properly or your functions aren't going to work. Use meaningful names. Give your artwork a name and print the name to the output. So like on the sample program. See, draw a picture using the turtle. You can pick the subject of your picture. If you want to make circles, you want to make flowers, you want to make squares, whatever you want to do. But you could make a house, a car, a face, a robot, whatever. In addition to the main function, you have to have at least 2 programmer-defined functions. And use at least one color besides black. You should have some kind of color in there. Put your pseudocode. Here's what other people have done. And this would be functions like the windows could each be their own function. Flowers next to it's their own function. However that works. Put your code, put your screenshot, and answer the questions. So let's play with that for just a moment. So if I went back here, and I went to page 3. Oh, this is page 3. I'm on page 3. And I said, okay, I'm going to go to the last screen because it's got a nice program there. If I copy this, open up idle, paste that program in here. Now I can play with it in here if I want. Oh, I got a bigger output window here. But if I want to start with this and then make my own functions, draw square. Well, I got to spell that. So I'm not going to draw a tree anymore. I want to move it to a position, pin down, and then I would change this to be something to draw a square. So I'll make a brown square, pin size 8, go forward 60, and then left 90 degrees, right? Isn't that how we did that? And yeah, we'll take off the leaves part because I'm not drawing leaves. And I also learned if I'm going to draw a square, I can put that in a loop for X in range 4. See, do I have to have a colon after that? I don't remember. Let's see. Did that work? Oh, draw tree. Yeah, because I changed it to draw square. It's trying to draw a tree. Did I capitalize the square? I should have. Okay. Does that work? Yeah, look. So I did a for loop, and I did a for loop because I wanted to loop 4 times, and I want to go left, turn. I'm going to go forward, turn, go forward, turn, go forward, turn, go forward, turn. I can make it not quite as thick a square, but. So I used this first function to draw a square instead, using the for loop that we used last time in our last program. So you have options of things you can make, and I use their program as a start. I may take off this draw flower and change it to something else. Maybe I'll draw circles and put parameters of the diameter and where the circles are going to be. You know, I can take off all this stuff about the stem and, you know, and just make shapes with squares and circles, whatever I want to do. Or I could draw a house, or I can do whatever. But anyway, I have to write a program to have at least 2 user defined. Oh, and of course I got to have my name at the top and the date, which is wow, is this day the 9th? Wow. Okay. Mr. Brock, 12/9/24, writing functions. Import the turtle. Draw a square. There's a function to draw a square. I can change this and draw circles. I can work on that. But then you have to have your main function where you call these functions. So that's really what you're writing. That's really what you're writing this time. So when I had this program that I showed you before, I could easily change this program that I wrote before. Oh, that's not indented properly. I copied and pasted it. See, the one I wrote before, I just had the define main, and all these have to be indented, but I would come back and fix that. And I just broke it apart. I had house. So I could make that a separate function. I could move all this house part and the roof and the door. So I could move all of that cut, and I could write a whole nother function up front. Define house. And then put that under there. And I don't have to have necessarily any parameters since I've already got everything in there. I got to dent that over because that's a loop. I got to have everything in my function indented. And I see a lot of stuff in here that I could change it to just send the parameters from the main. So now my program starts down here at define main. And I could just call it draw house and not send any parameters. So if I defined draw house up here, see if that works. Oh, 9/9. I messed something up. Oh, because I did not. I got to put this after I define my turtle. Donald draw turtle. So let's put our define house down here. Draw house. Still doesn't like it. What am I missing? Donald forward 150. Oh, because that's a loop. I didn't indent that. That's a loop. Oh, now I messed up. I got a lot to fix if I do that, I guess. Oh yeah, because all of this is not indented, so it's giving me trouble down here. Anyway, I could change these things to separate functions. Every time like a wreath, I could put that in its own function up top. Define, draw wreath, and all those things. All of those things. You can play with the functions. I would start by going to page 3 of our lesson and playing with theirs and understanding how their functions work. Okay. Define main is where your program will start, but it will go up and call these functions that you actually have already created up above the main function. So play with page 3 before you start writing your own. And you can copy parts of that and use that as a base, but you can't turn in that program. You got to have your own program. So you got to define your own functions, not the functions that it's already written there. But use that as a good starting point. Copy it in there and say, okay, now what do I want to change? What do I want the function to do? But at least you can have some starting code. But don't forget to put your name, date, and all that stuff at the top. Don't forget to put your pseudocode. Start with your pseudocode. Go to your there and say, what do I want to do? I want to use define a function for drawing squares. I want to define a circle for drawing triangles. I want to define a function for drawing circles. You could have 3 functions. You just have to have at least 2 that you create. You could do 3. And then I'll have my main function, and I will draw 2 squares, and I will draw 3 triangles, and I'll draw 4 circles. And I will name it and print the name of the output. Because remember, that's part of it. You got to name your, and I'll say geometry, and I will draw triangles, squares, and circles, and I'll, whatever you want to do. Use your imagination, have some fun with it, practice with your graphics, but you get to create your own functions now. So we're going to know how to do that going forward. So, all right, guys, we're out of time anyway, because cybersecurity is going to be here in just a few minutes. So have fun with this. Play with these functions, play with the graphics, figure out what you want to do, write your pseudocode, and then put your program together. If you got questions, this is a B Day Friday, so I'll only be here on Wednesday, but email me if you get stuck on anything to do as well. So otherwise, we will meet next Monday. We won't have the final till Wednesday because we're going to meet on Wednesday for the final, but we'll meet next Monday. And you guys have a great week. I'll see some of you on Wednesday. The rest, we'll knock out this last program.